PyTorch. So Facebook just announced a new uh, PyTorch version 1. Um, so I'm just trying to understand and test it. I'm new to PyTorch. I'm going to create a new Python 3 notebook and see how it works. Just gonna close this. Still loading. So I'm just reading here the PyTorch tutorial. It says that PyTorch actually is a replacement for NumPy to use the power of GPU. Huh. So I guess NumPy doesn't use GPU. That's my assumption is. Unable. What? Why? Okay. I don't understand. Sometimes it's kind of like hang. That's so weird. Um, it works like this. Come on, come on. Open up, open up. I don't understand why it doesn't want to open. Why? Is it already at night? Hmm. Doesn't want to open. I don't know. I have no idea what's going on. Should I? Yeah, I just close that one first. Unable. Really? Okay. Remote parts using virtual worker. Untitled. Probably I should do untitled. Yeah. Okay. And I'm just gonna click runtime, change runtime, uh, GPU. Okay, and then just gonna click uh, PyTorch tutorial. Okay, and then I'm just gonna delete this. Okay, good. All right. Okay, so basically it's a replacement for NumPy, specifically designed for GPU. So it's parallel processing, and it's a deep learning basically framework for deep learning. As you probably already know, but I'm just gonna repeat again that deep learning is part of the machine learning, right? And machine learning is part of artificial intelligence. So one of the machine learning algorithm, um, there are basically machine learning comprises by two big camps algorithm. One is the shallow learning, and the other one is the deep learning, right? Um, so this is kind of a programming language, or as you can say, it's like a framework that's specially designed for deep learning to provide maximum flexibility and speed. So we'll see. Okay, so like what Facebook claimed that this is a replacement for NumPy. That's even more powerful than NumPy. Okay. Okay, so tensor are similar to NumPy and the arrays, with the addition being that tensor can also be used on a GPU to accelerate computing. So let's do from future. Oh, wow, that's cool. Boom, boom, import, print function, and then import torch. See if it works. It says no module name torch. If your import is failing due to missing package, you can manually install dependency using other people. Okay, install. Huh, okay. You have to install Torch first. So you have to download this one. I didn't know that. Insert. Okay, okay. See what happened. Executing. So it says here HTTP pytorch from OS part import exists from will pip. I don't know what is import get platform format. CUDA accelerator CUDA output if exists. All CPU pip install torch. Hmm. How come it doesn't say anything here? See how about get started here. Start locally. Start via cloud partners. This is gonna take some time. Oh, is it done already? Okay, cool. Um, let's do this. Put it, let's execute it again. Okay, it seems to work. Um, where is that? Okay, okay, okay. Let's do this. Let's construct a 5 by 3 matrix. So five rows and 3 columns. So x equals to torch dot empty is an empty matrix 5 by 3. Oh, and then you're gonna print x. Seems to be simple enough. Boom. Okay. Yeah, it reminds me of NumPy. Um, Okay, so far so good. Now we want to construct, let's say, randomly initialized matrix. X equals to torch ran 5, comma 3. It's pretty intuitive, right? I mean, the syntax is pretty simple, okay? So this is random initialized. So you can see there's 5 column, sorry, 5 rows and 3 column. That's how we write matrix. So the first one is the rows and the second number is the column, right? Okay, what else can we do? Let's make a matrix, construct matrix filled with zeros and data type long. Okay, so X torch zeros 5 comma 3 comma D type plus torch dot long. And then just want to print the X. How about if I just put X? Will it work too? Oh, actually it works. It's the same. Huh. It's the same. You can just put X instead of put print X. Okay. Okay, let's construct a tensor directly from the data instead of um, as a comment. Right, towards tensor. Um, let's say just two elements, right? Let's see here. Oh, I'm just gonna make it bigger. Sorry, guys. I'm gonna make it bigger for you guys so you can see better. There you go. Is that good enough? All right, and then just gonna print it. Oops. There you go. So you basically now create a matrix directly from the data, right? So you want to put this dot tensor, and then uh, and then you put the element. Yeah. So the difference is over here. It's a comment, right? You don't put the data inside. You just put what are the dimensions of your matrix, right? The rows, number of rows, and number of column. But this one, since you dot tensor, so you have to put the data directly there. Okay. Okay, what can we do next? We can create a tensor based on the existing tensor. So you can use this method to reuse properties of the input tensor. For example, data type unless new values are provided by user. Okay, for example, so if you have x equals to x dot new ones and 5 comma 3 comma d type, well, torch, say double, right? Um, okay, let's print that x. So it's just all ones, 5 rows and 3 columns with data type, double data type. Okay, and then let's create x equals to torch ran uh, random like x. So you notice that we are using the existing matrices or tensor, right? So here we put instead of the element of the matrices, we put x is basically is a tensor, the one that we already defined here, which is this one, right? So the command is for that is random like ran rn like, okay, and then we execute that. It should give you the same. Oh, wait. Oh, hold on. What's happening here? You randomize it, I guess. Hmm. That's random like. Yeah. I don't know what to do with this. To randomize it. Data type. Well, it's using the same dimension though, right? It's basically exporting the same dimension. Yeah. Okay. You can get the size. Size. Okay. 5 by 3. So torch cell size is a tuple. So it supports all tuple operations. Tuple is immutable. Um, cannot be changed, I think. I kind of forgot already what tuple is. Is a list, like an array. Okay. Okay, now operations. What can we do? There's multiple operations, syntax operation. For example, we can do, let's say, v equals to torch, um, just addition, right? Print x plus y. Okay. Um, you can do add to, say print torch add. Can do it a different way. Should be the same. Yeah. What else can you do? You can provide an output tensor as an argument. So as a result equals to torch empty empty 5,3 and then torch at um, x comma y out equals result. Okay, and then print result. Okay, so what's happening here? We'll see before I execute this. So you're creating a variable called result. Okay, and then you're calling a torch framework, particularly the empty um, 5,3. Okay, so result now is holding that dimension of torch 5,3 empty. And then you want to add x comma y and then out is the equals result. So I think out. So let's see. Yeah, okay. So if you can see here, if you want to print like result here, just print result here. So we're gonna see what is the difference. It should be it should be all empty. It's just set initialize it. Okay. So it's like that. It's almost zero. So it's like very small number, right? I guess it's not totally zero, but it's like a really small number just to initialize it. Um, I guess you can do okay. I guess you can do zeros here. Yeah, it's still the same, right? Just put empty. Yeah, the result is still the same. Okay, so yeah, that's anything else you can give, for example, addition in place. So let's say add adds x to y. Um, y add x, just like that. That's pretty cool, huh? Pretty cool. What if you could do this? Hmm, it's a tensor. Okay, it's a tensor. But if you do this, it's the same. It's the same, man. 1 minus 3, 4. Oh, oh. I think because it's keep on accumulating. Yeah. I mean, the y there is not the same anymore. Okay. Hmm. Let's see what else can you do. Oh, you can use standard NumPy indexing, for example. Um, okay, let's print x again, right? I do not know what x. Okay, that's x. You can use like the one in NumPy. So it seems like compatible with NumPy syntax. You can print what's it? The second row. This one, right? It's a bit weird the syntax here. What if if you, let's say, I don't really understand that. How does it work? Because it's printing a second row. What if it's like two? Hmm. So this is zero, this is one, this is two. Okay, got it. Because this is printing a column, right? Okay. So if I do this, it shouldn't work. Or, well, it could work. It could go back. It's out of bounds. Okay. So it starts with 0, right? Yeah, start with 0. Um, and semicolon here is just, it just means that uh, you're not printing anything for the rows because this is the rows, right? Um, so you're letting it pass. If you do that, I wonder what happened. Invalid syntax. Okay. How about if you do this? I think it will put one. Yeah, this one and this one. Okay, got it. Or you can do this the opposite way. So it's gonna print the first row. This one. Yep. There you go. All right. So semicolon means you passed it. You don't want to do anything. You're not doing anything. That's what semicolon means. It means you're skipping it. Okay. Um, okay. Another example, if you want to reshape the tensor, you use torch view. Okay, torch rn. Oh, what did I do? rndn. There you go. It's random. Okay, we got the random one. And then what are we gonna do with it? We're gonna do y equals to x view. View means you want to reshape it to 16. Okay, let's print. Let's print it. So I want to know what it looks like, right? Whoa, okay. So into 16. So means only 16 elements. Oh wow. One, two, three, 4, 5, 6. Well, there is 16. What if you just put 10? Can you do it? No. Oh, you cannot do it. So it has to be the number of element. Okay, got it. Just the number of element. The total number of element in one long row. But what if I want to do, let's say, z equals to x view minus 1 comma it. Let's see what will it be. Oh, okay. This is a bit weird because it's completely the same. It's completely the same as the y, right? So what's the different here? Is inferred from other dimensions. Let's print um, x dot size. y dot size, z dot size. Let's see. Okay, so x size, which is this guy, okay, is 4 by 4, right? Y size is 16. Oh, so the difference is the z is 2 by 8. Okay. Yeah, I didn't see the bracket here. See, this is a bracket over here. There's no bracket. So it belongs in one row. This whole thing here from here to here. Oh, sorry. From here to here, that belongs to one row. While the one over here is from here to what? Yeah, to here. It belongs to one row, right? Uh, that's the difference. Okay. Okay, what else can you do with PyTorch? Some basic elemental thing. Um, so if you have one element tensor, you can use dot item, okay, to get the value as a Python number. Okay, so for example, x equals to torch, INDN, so only one element, right? When you see it, okay, one element. So you can do, let's say, print x dot item, okay, to get the value. Okay, if it's just one item. Okay, that's fair enough. Um, yeah, so this is just basic operations that you can do. Just give you a bit of like taste and yeah, but what PyTorch can do with regards to the similarities with NumPy, because the way it's being described again, PyTorch is supposed to can be and supposed to replace NumPy and is for graphical processing unit for GPU, which means it's supposed to be faster because it's parallel processing and is a framework specially designed for deep learning, right? And deep learning uses a lot of parallel computation. Okay. Okay, now there's a thing called NumPy bridge. So converting a torch tensor to a NumPy array is a breeze, and vice versa is a breeze. Torch, tens, torch, tensor and NumPy array will share the underlying memory location, and changing one will change the other. Okay, so they both share this the same memory location, the underlying memory location. Okay, okay. So example of changing um, um, or converting torch tensor to a NumPy array. Let's say a equals to torch ones 5. Okay, let's print that. So we got a tensor or a factor of all ones with 5 elements, right? Over here. Right, okay. And then we want to, we are going to convert it into NumPy, right? So we're going to do b equals to a which is torch tensor, right? And then just dot numpy like that, and then let's print it. There you go. So it becomes a numpy, right? The name is array instead of a tensor here, right? And you can see also, for example, what can you do here? Yeah, what if, let me see. Okay, let, let me see, print. Okay, just use print A, okay, and print B, okay. You can see how a numpy array changes in value. Okay, so A dot at when print A and print B. See what this does. Okay, let's see. Okay, so A, where's A? A is this one, tensor 1, 1, 1, 1. Yeah. You add 1, so it becomes 2, right? And then you print the A again. So this is the result, right? Which is correct. It's a torch, pytorch tensor, right? And but the one below, even though we don't do any operation, it's because it's associated with b equals to a dot numpy here, right? So even though we don't execute it, it affected the the result of the b too. It's also 2 because what happens is if you associated uh, a torch tensor to a numpy or a numpy to torch tensor, vice versa. If you change one or the other, so if you change the numpy or if you change the tensor, it will affect the other because the torch tensor and numpy um, share um, the same memory location, right? That's magic. It's magic. It's magic. Okay. So we can use another example to convert um, numpy array to dot tensor. Okay, let's see how it goes. So I'm just gonna um, import numpy as np, and then a equals to np ones 5, right? And then b equals to torch from numpy. Hmm. Okay, and np dot at a, 1, out A, and then print A and print B. Okay. So what happens? We're creating a NumPy array of ones with 5 elements, and we put it on A, right? So it's gonna be like I think it's gonna be like this, right? And then we are also creating a tensor torch, right? From NumPy. Here is from NumPy. Oh, what did I do? From okay, from NumPy, and then after that you want to add that the A with one, right? Um, and then the out it's A. Okay. Um, so okay, let's print this. It should be oh, that's it's not divine. Oh, yeah, yeah. Okay, it should work. There you go. See, so you when you change the A, only the A, we're changing the A here. The tensor also changes. Yeah, so it's convert NumPy array to dot tensor. Okay. Um, CUDA tensors. Never mind about this. Okay, I think that's all for now, guys. That's just a brief introduction of what PyTorch is. Thank you for watching.